we're here in New Orleans at American Clean Power 2023 with Nicholas Gaudern, CTO of PowerCurve. And one of the discussions this week, Nicholas, has been about repowering. Obviously, the IRA bill has a lot of money in about repowering. Discussions revolve around what's involved in repowering, like what can be considered as part of the tax credit. And one of those items is aerodynamics. Fixing the blade structurally, which is what Wind Power Lab does, and giving, understand repair plans there, which everybody's doing right now.
Right.
But while you're on the blade, you might as well get some AEP back and get some aerodynamic performance back. What are the people saying here this week?
No, I think it's a really good point, Alan. We've had some great conversations in the last couple of days about what is applicable for the tax credits, and basically everything. Like all these aerodynamic upgrades that you can put on, it's all worthwhile doing if you're on the blade doing other work.
It's just a dollar value, right? At the end of the day,
Absolutely.
you got to spend so much to qualify.
Yes, absolutely. And if you get AEP back in the same time, perfect.
Yeah.
So something we've been talking about a lot is vortex generators. We've had a lot of interest in VGs as part of that work because it is a bit of a no-brainer, really.
It's easy to do.
It's easy to do. It's cheap to install, and you can not only recover AEP that you'd be losing through, say, contamination and erosion.
Right.
You can also just improve the baseline aerodynamic performance of the blade. And it's one of those things that it's a very low risk. It's a low risk investment.
Sure.
Tried, tested, proven. I don't think anyone's going to argue that a VG works or doesn't work.
Right.
But we've also talked about things that you could maybe consider a little bit more exotic, things like tip extensions, for example.
So just basically making your blade a little bit longer.
Yeah, exactly.
Especially where most of the power is generated anyway, it's on the outer third, so making another meter, 2, 3 on the tip.
Yeah, exactly. So I think with a tip extension, it's all about getting more swept area. The bigger the swept area, the more power. It's kind of obvious. So it's an easy thing, I think, for customers to understand. There's not any particularly complicated physics around it. It's just bigger rotor, more power.
Yeah, those are formulas that we all know and love.
Yes.
Right? That's not a hard one.
We can take an older turbine, let's say, a 60, 70 meter turbine that might be knocking around and eligible for some credits. If you just put a meter of blade length on, you could be looking at 3% AEP.
Whoa. That is huge.
Because, you're going from a 61, 60, 70, whatever, you're putting another couple of meters diameter on. That's a lot of swept area increase.
Yeah, and think about if you're going to drop the rotor to swap out main bearings or a generator or something of that sort. That thing's on the ground. If you've got a good operational plan, you can install those quickly on the ground. The ROI on that is going to be very quick.
It's a lot of AEP for not much money.
Yeah, exactly.
I mean, it's a bigger job than a VG install, of course.
Sure,
so
absolutely.
if you're doing a tip extension, you've got to think a lot more about the structure. You've got to think about how you're bonding that on, how it integrates with a lightning system.
Yes,
as well.
Absolutely.
Do you need to supplement the lightning system or do anything around that with the extra blade length? I mean, none of these problems are insurmountable.
No.
Right.
But it's not an on-the-shelf product. So the things like a VG, it's on the shelf, it's designed, the components exist, and you put them on and they work.
Right.
Things like a tip extension, it's more of a bespoke engineering project. There's just a little bit more to it. So again, quite well suited to a bigger investment in your machine, where you have the money and the time available to do it properly.
But you're hitting a sweet spot in the market there too, right? Because talking to people, you can talk till your face is blue about a tip extension to someone that's under warranty, and they're just going to glaze over, right? No. So that we're talking here, PTC-driven repower projects. It's the perfect time. That asset's 10 years and 1 day old at least, right? So it's been around the block. It's out of warranty. It may be under an FSA or something as well too, but that at that stage, the asset owner has a little bit more power to make decisions for themselves rather than the OEM driving basically what happens to the turbine.
And that's what you need. You need an owner who understands the turbine, is familiar with it, it's not in warranty, and is just prepared to just take that little bit of extra investment and risk to maximize performance.
Absolutely. So talking repower here now, like Alan, you were saying, around the show, I mean, we talked to a lot of the big ISPs. We talked to a lot of asset owners, and it's PTC-driven repower. We talked to one ISP that they're more of a service-oriented one, and they don't really do blades that much. And from a project that actually the three of us worked on together was a PTC-driven repower, where we went in and inspected the blades, internally, externally, did a big repair campaign to get them to, up to a like new status. Client wanted some AEP increases. So we put on Gurney flaps, we put on vortex generators. Yes. And then we also did, on our side, we recommended an LEP campaign.
Right.
And then we also added the strike tape product to protect them from lightning in the future. Right. So we reduced lightning risk. We increased the AEP. And we kept those blades we have a GEV Wind Power went out there and did the big campaign on. We kept those blades out of landfills.
Yes.
Right? So that big picture of the blades in landfills and all that problem, hey, we just kept them running.
This is exactly what we should be talking about. Yeah. Not throwing stuff away because it's 10-year-old.
Exactly.
Going out, there's so much life and energy potential in these machines. Go and use it.
Go
and exploit that.
Yeah, a lot of the blades that are being repowered right now are, again, 10 years and 1 day old. So they're 10, 12, 11 years old. They're designed for a 25-year life.
Yes.
Now, a 25-year life out of a blade is tough to get to, depending on your environmental conditions. But if you're doing a refurbish at 10 years, 25 is
and
easy.
when you start
30.
adding on the extra AP potential from some of these devices we've been talking about, that's making the business case for longevity so much better.
Yeah,
so
absolutely.
We're really excited about the potential, and we've had a lot of people talk to us about it. So I think we talked about VGs, Gurney flaps, serrations maybe. If you've got any kind of noise curtailment issues. I don't think it's as big in the US as it is in Europe.
Yeah, wind farms are more remote here for the most part. Yeah,
we have had some customers talking to us at the show about northeast US.
In my neighborhood, I'd say definitely serrations.
Starting to see a bit more demand and interest in noise reduction technologies. Yeah. So the thing is, if you have to curtail your turbine or at certain times of day to deal with noise regulations, you're throwing away so much AEP.
Yes. Oh yeah, absolutely.
So that's where you should be looking at actually attacking the source of the problem, not just trying to get around it.
Yeah.
Go to the source, which is the aerodynamic noise.
Yeah.
And then serrations, VGs can be used together to just reduce the noise at the source.
So, I mean, at this table right here, we're having a conversation that should be happening across the broader wind industry.
You would think.
Right? Refurbish and upgrade rather than take down and throw away. Yeah. Not only from, an ESG goal standpoint, we're adding power and you're saving cost.
Yes.
Right? I mean, I know that I've seen budgets where it's, on a GE15, say, $150,000 a blade for new blades.
Yeah.
And we can repair them to like new, upgrade them and everything for half that cost.
Yes.
Right. Yeah. And that's including all the people in the field and the new parts from PowerCurve, new parts from WeatherGuard, all the engineering that goes behind the whole solution, half the cost.
Yes.
And you're increasing AEP. It seems like a no-brainer to me.
No, we really, really want to support that because, it's just something that absolutely should be happening.
Yeah.
And the technology is there. It doesn't matter whether the blade is 10-year-old or 2-year-old. Yeah. The aerodynamic technology still applies.
Yeah, to be honest with you, a transparent conversation that we've been having a lot here at the show is the only stopper here is the workforce to get it done.
Really?
Right? Technicians. If you got 150 turbines that want to do a repower, to go and fix 450 blades and install all this stuff, it's just tough. It's tough to find the bandwidth in the repair season here in the United States to get that done.
And what are the time limits on the PTC? I mean, is that, how long is there for customers to act on this?
Yeah, when does it moonlight? The last project that we did like this was before IRA was passed, so we had to have everything done by December 31st last year.
Yeah.
And it was it's tight. So now that the PTC's been extended here for a while, I think
10 years.
This is going to be an ongoing thing.
It's amazing. I also, from what I understand, I don't know the details, but I understand that it's good if you have some local content. It's a
part of the new IRA bill.
If you're going to be US made, and that's something that, again, we've been looking at today. So at the moment, PowerCurve, we're a Danish company, our production's in Denmark.
Yep.
But there's absolutely no reason that we can't look at production in the USA for add-on components.
Yeah.
Injection molded components, I'm sure there's great injection molded companies in the US.
Yeah, sure.
So we can actually look at producing locally if that's helping our customers to meet PTC requirements, meet goals, bonuses, whatever. So
that's definitely a good point to touch on.
So we're investigating that heavily at the moment to see what we can do to really maximize the opportunities with this PTC.
Yeah, and I'd like to speak from a personal note too on the supply chain. So I've dealt with PowerCurve in the past, and supply chain with you guys, no issues.
Yeah.
Right, we know that right now it's tough sometimes to get resins and plexus, and it's nothing against the manufacturers. It's just this stuff has happened coming out of COVID and adjusting to a lot of things. Supply chains are you got to be stringent, right? You need if you're a decent sized company, you got to have a supply chain manager to make sure you're getting all your stuff.
Yes.
And dealing with you guys, even though it came from Denmark, no issues. It came
good
well.
to hear it.
Yeah.
Good to hear
so
it.
kudos.
Yeah, but if we're in the US, we can be even faster.
Yeah, exactly. So it can only get better.
Yeah.
So what's if I in the United States, let's just pick the biggest player in the United States, which is GE, right? So there's a lot of GE 1.5s, GE sort of
1.X's, yeah, 1.6s, 1.85s, 1.7s,
right, all
yeah.
To do an upgrade aerodynamically, what information do you need to know? Do you just need to know the blade length, and that tells you everything, or you need to go out and do a blade scan? What's the process to increase AEP in a repower situation?
Yeah, so it's a good question. So we've established a pretty rock solid process now.
Okay.
And it does start off with knowing the exact blade geometry.
Okay.
So we would want to know the blade type. Because even if it's a GE 1.5, 82.5 meter rotor, there might be 2, possibly 3 different blade types used on that platform.
Right. TPI
exactly.
or Texas.
Yeah. And they have
or
different shapes.
LM. I
Yeah.
guess,
And then that means if the blade shape is different, the optimal aerodynamic upgrade configuration will also be different.
Right.
So we'll go out into the field. If we haven't done it already, we'll get a laser scan of one of these blades to build a CAD model. Okay. I think on a previous spot, and we talked about the laser scanning process quite a lot. So once we've got that CAD model, that becomes the foundation for building the best upgrade pack. So get the CAD model of the blade, do a lot of aerodynamic analysis like computational fluid dynamics, CFD, and then just look at every nook and cranny of that blade's performance to basically do like a blade aerodynamic health check, understand everything, get the signature of it, and then look at where you can maximize every last bit of performance along the blade.
And how much information do you need about the winds at a particular site to help you do that analysis? Do you need a lot of data there? Because with the Met Towers, and if they've been out in the site for 10 years, they should have a lot of data about
I mean, as a minimum,
and...
we just want to know like the site average wind speed, to be honest.
I
mean, more information is always nice, but fundamentally, site average wind speed is enough, but it's more to determine the business case more than anything. In terms of the design, the components, it doesn't really do a lot.
You could say, hey, give me a year's worth of low-res SCADA data, and we'll figure it out.
Yeah.
This is what your power increases look like across the 12 months.
And the reason it's interesting from looking at the AP percentage potential is that the more time you spend below rated power, the more benefit, percentage-wise, you'll get from an upgrade. With things like vortex generators, they don't change rated power.
No.
They just boost power below rated.
Right. More efficient.
Exactly. So as soon as you hit rated, they're not doing anything. The turbine's pitching, it's being controlled to hit rated power.
Right. If you, I don't know if you can really reveal this, but your library of blades that you guys have now, how many are in it?
We're around 30 different blade models.
That's going to cover a lot of the market.
We're covering a lot of the existing market in the US.
Oh, that's fantastic.
Yeah, for sure.
And so we talked about repower and blade tip extensions being ideal for a customer that knows their turbines and they're 10 years old out of warranty. What about just vortex generators? What if someone just wants to add some AEP and that turbine's it might be just out of warranty or something of that sort? You guys get a lot of customers that are doing that?
Yes, and we'll always start with vortex generators.
Yeah.
That is the first thing we'll look at as an add-on because it's simple, it's proven, it's cost effective.
Yeah.
So those components are absolutely where you go to first.
Right.
Things like a tip extension, as I was saying, it's a bespoke engineering project.
Yeah.
You can do it, and it may be
extreme,
worthwhile on the PT, but it's a bit more extreme. You've got to take the loads into account a lot more. If you're putting length on the blade, mass on the blade, you're going to want to do a more detailed load study, structural study. So again, all this is surmountable, sure, but don't go there first.
Yeah.
Start with the low-hanging fruit, use the proven technology, then start looking if you have the budget and the risk appetite.
Yeah.
Then start looking at these bigger engineering projects for things like tip extensions.
So if you're an asset owner, and that's not just a U.S. thing, if you're an asset owner globally, and you've got a little bit of CapEx space or a little bit of O&M, give the PowerCurve guys a call because they can calculate the ROI for you based on percentage that you should gain and be able to tell you when you're going to pay these things off.
Right.
And then for the rest of the lifetime of that turbine, you're making more money.
Absolutely, yeah.
I got a quick question here. How does LEP play into the VG equation? So a lot of upgrades. Discussion on the floor this week is we're putting shells on, we're putting on coatings on. There's a lot of variables there. if you know that ahead of time, does the VG layout change, or do you know you have a little bit of a step on, like the shells have a step, and that's an aerodynamic deficiency? Do you have to take that into account?
Yeah, we would, if we have that information, we would take it into account in the design process. And I think you mentioned a few different styles there, you know, shells, tapes, paints.
Yep.
The interesting thing is that they all have an aerodynamic impact themselves.
Yes.
You know, just the fact you're modifying the shape of the leading edge,
right.
You're maybe putting some roughness there or some steps there, that in general is detrimental to aerodynamic performance.
Okay.
Now, I don't want to start scaring people. We're not talking big numbers, maybe tenths of a percent AP. But, you know, that's still important. And the difference between a shell and a tape or a paint is going to be different.
Thickness.
And will that affect the layout of VGs or a plan for Gurney flaps or something like that?
It would impact layout for outboard vortex generators, the ones near the tip.
Yep.
Everything else it wouldn't affect.
Yeah.
But let's say you had an LEP system that did change the leading edge shape considerably.
Mm-hmm.
It may be that VGs can play a big role in mitigating some of that negative impact from the LEP being there.
Yeah.
And, you know, as I say, there's not a one-size-fits-all answer. You have to look at the aerodynamics of each and every solution and decide what's best. And one thing I would say is don't just blindly put on LEP. You know, if you've got a blade that fundamentally is okay, there's a little bit of erosion, but not much, it may be putting on LEP loses you more AP than you're going to gain back.
Right.
That's maybe more of an extreme scenario, but it's still something that should be calculated and looked at. You know, don't just slap on a third of the blade covered with LEP.
Yeah.
Work it out. You know, look at the potential losses, the gains, mitigating factors, and make the decision around the aerodynamics, not just a structural decision.
Yeah.
It kind of brings me in mind of a conversation I had last week. I was at an Energy Insurance Americas conference, and it's the same thing here. For everybody, a note: there is experts out there.
Yes.
Right? You don't have to just cowboy the things up and we think we should throw this and think we should throw this. Call the experts.
Yeah,
right? We always say, like, if it's an aerodynamic thing, call PowerCurve. If you want to talk lightning, call WeatherGuard. If you know, like blade fatigue damage, just like call wind power. Like there's experts out there, whether you're an asset owner or you're an ISP or you're a service company or you're fixing blades or anything. Call the people that know what they're doing and get it done correctly.
Yeah, I think talking about LEP, because we have aerodynamic models of blades, we can model the LEP.
Yeah.
We can model the impact of it. So again, you don't need to guess. Take the guesswork out of it.
Yep.
Work it out. Make the right decision based on the data.
There's data and knowledge there. Use it.
Yes.
Yep.
And don't put VGs in front of your lightning protection system. Can we just say that?
Yeah.
Because lightning and aerodynamics are tied together, and I see these upgrades happen that are just a little helter-skelter.
Yep.
And even some of the OEMs, I've seen some OEMs do this, where they start putting aerodynamic fixes where the lightning protection system is, and it degrades the performance of the lightning protection system. Then they wonder why they're having lightning damage. Well, those AEP fixes
keep a clean zone locally.
Yes.
Around the lightning system.
Give it some room to work.
Yeah, we're not talking a huge. Just leave a meter.
Yes.
Leave a clean zone. Don't start drilling holes in blades, putting drain holes in, putting lumpy bumpy things. LEP.
Putting LEP in front of the lightning protection system.
Yeah.
Why are we doing that? I'm still dumbfounded by that, but.
Well, it's a system integration thing, isn't it?
It is.
It
is. Aerodynamics is working, and they're trying to improve the blades, absolutely. Lightning protection, people are not really thinking about what the impact is there, and then the operators get handed a big bill.
With a lot of engineering problems, there's just, you need to take a holistic approach to this. Take a system-level approach. Aerodynamics, structures, lightning, control loads, they're all linked.
Yeah, they're not independent.
So consider them together. Yeah. And
that's what PowerCurve's good at.
Yes.
You can look at all those things together in a really accurate, finely resolved model that makes it almost obvious, even to the novice like me. I've seen a lot of your products, and I don't know a lot about aerodynamics, but I can tell where clean air is and clean air isn't from your models.
That's why
really good.
Why he put his kid into school for CFD, right? See, he's trying to build that knowledge at the dinner table at night.
Well, that's what you should be doing.
Yeah.
That's what you should be doing. So, and the more aerodynamic knowledge in the world, the better. In my opinion.
So, Nicholas, thanks for being back on the podcast. It's great to have you in America again, in New Orleans. We'll see you in America at next year in Minneapolis.
Yep.
I think before that we'll be at O&M in San Diego.
Oh,
Is it back in
nice.
San Diego next year?
From what I read, yeah. Yes.
That'll be awesome. All right. Fantastic.
Great
All
to
right.
chat to you both.